Ladies and gentlemen of Algebra 2, we're talking about 4.1. This entire unit is everything and anything having to do with quadratics. Quadratic is anything with an x squared in some way, shape, or form in it. You guys have seen this before. This is going to be kind of going a little bit deeper, and right now what we're talking about is graphing those. When you graph a quadratic, it looks like this, okay? This is called a parabola. Okay, so when you see parabola, that's what the graph looks like. Most of you guys might also be familiar with it looking something like this, okay? It either can open up or open down. So when you take a look, rock music managers handle publicity and other business issues for the artists they manage. They use a function such like this, where X is the price per ticket in dollars. What happens to the income as the ticket prices rise? So if you sell it for a ticket price very cheap, you're not going to make very much money. As you kind of increase the cost, somewhere around 40 bucks is where you're going to make the most amount of money. As you go higher than 40, income is going to go back down. So what they're looking for is kind of that sweet spot to where they can charge the best amount to make the most money. All right, so that's kind of what's happening here. All right, this is where your income is. 0 would represent where you make absolutely no money. All right, so right down the middle, that would be at 40, and that would be probably a little bit over $70,000. So a quadratic function looks like this. So looking, this is what the quadratic function looks like. So anything that has an x squared, and after that it's kind of up for grabs. But mostly what I'm looking at is what's A, what's B, what's C. And I'm doing that because that's going to help me find kind of the big pieces that are going to help me graph. Okay, so the axis of symmetry, negative B over 2 times A, that's utilizing this A and B, which comes from the function. All right, C is going to be the y-intercept. All right, so this number right here ends up being the y-intercept. The number by itself is the y-intercept. So when I look, if A is positive, it's going to open up. A is negative, it's going to open down. If it opens up, that means there's an absolute bottom. That's called a minimum. If it opens down, that means there's an absolute top called a maximum, meaning the highest it's ever going to get. Minimum, obviously, the lowest it's going to get. So when I look at this function, I'm looking at graph. Well, right away, I'm looking what's A, what's B, what's C. Well, A is 1, B is negative 6, C is 3. C is my y-intercept, so that's 3. So that means on the graph, I'm putting a dot right at 3. All right, so vertex, axis of symmetry, that's that negative B over 2 times A. So that means negative 6 over 2 times 1 is going to equal 3. So 3 would be my axis of symmetry. So that means I'm going to draw a dotted line coming down 3, okay, where x equals 3. Then to figure out my vertex, I'm going to put that into the function and see what happens. So I'm going to put 3 into the function, 3 squared minus 6 times 3 plus 3. So that's going to be 9 minus 18 plus 3. And then see what I get. 9 minus 18, negative 9 plus 3 is negative 6. So that means my vertex is at 3, negative 6. So that means my starting point is there. So now I'm almost done graphing. All I need to do now is mirror this on the other side. Mirror the y-intercept on the other side. You see how it's 3 units away, 3 units away? That gives me enough to say, yeah, I want to draw that right there. So there's my graph right there. But remember, all I did, take A, B, C, C is my y-intercept, use negative B over 2A to figure out my axis of symmetry, then substitute this number into the function to figure out the vertex. So here, 4x squared minus 8x plus 2, so A is 4, B is 8, C is 2, so y-intercept is 2, axis of symmetry is going to be, that should be a negative 8. Negative B over 2 times A. So that's going to be negative 8 over 2 times 4. All right, so y-intercept of 2, so I'm going to put that there. So when I simplify this, that's going to be, I get 1, so my axis of symmetry is at 1. So as I kind of fill that out, so then substitute that 1 in to the function for x. 4 times 1 squared minus 8 times 1 plus 2. So that's going to be 4 minus 8 plus 2 equals negative 2. So my vertex then is going to be just 1, negative 2. There you go. So now, mirrored on the other side of the axis of symmetry, there's my graph. All right, so an object is fired straight from the top of a 200-foot tower at a velocity of 80 feet per second. The height, h, of an object t seconds after firing it is given by negative 16t squared plus 80t plus 200. Find the maximum height reached by the object and the time that the height is reached. So negative 16t squared, you'll see that occasionally. That's gravity, and that's in like feet per second squared. So that's that one. So what they're looking at is it launches 80 feet per second. It starts off 200 feet in the air. So what do I do here? So this is just going to be a fancy way of saying negative 2 times a. All right, now think about this a little bit. You shoot an object into the air. Well, eventually it slows down, gravity takes over, it comes back down to Earth. So what we're trying to figure out is, where is that high point? Where does it top out at? Well, that's just going to be the axis of symmetry and the vertex, okay? So when I draw this, so when I write this, that's what I'm looking for. I'm basically, is a fancy way of saying, figure out the vertex. So if I do negative b over 2a, that's negative 80 over 2 times negative 16. So that's going to be negative 80 over negative 32, which is going to be, I think it's 2.5. So that's going to be 2.5. So after I launch this thing, 2.5 seconds, that's when it reaches its highest point. All right, so that's going to be when it reaches its highest point. To figure out what the highest point is, I'm going to substitute 2.5 in for this. So I'm going to go negative 16, 2.5 squared plus 80 times 2.5 plus 200. So 2.5 squared times negative 16. So this will be negative 100. 80 times 2.5 is going to be 200 plus 200. So that's going to be a total of 300. So, long story short, after 2.5 seconds, it is 300 feet in the air, and that's my highest point. That's a blank one. So, Libby throws a ball in the air with a velocity of 64 feet per second. 64 feet per second, I feel like that's important. She releases the ball 5 feet above the air. Here is my velocity function, where t is time. She launches it with 64 feet per second. She starts off 5 feet in the air. So find the maximum height that the ball reaches and that the height and the time at this height. So I want to figure out the time and the height. So I'm going to take negative 64 over 2 times negative 16. Again, negative b over 2 times a. So that's going to be negative 64 over negative 32. So that's 2. Now I'm going to substitute this in here. So what I do is this. So negative 16, 2 squared, plus 64, 2, plus 5. So that'll be negative 64 plus 128 plus 5. So 128 minus 64 plus 5 gives me 69. So after 2 seconds, it's 69 feet in the air. That's my answer. That's my solution right there. That's all I got. Hopefully some of this looks familiar to you, like you've seen it before in algebra. If you got any questions, come and talk to me. But again, big pieces, big pieces. you've got a quadratic. That gives you your axis of symmetry. Okay, substitute that in for x. That gives you the vertex. C is your y-intercept. There's my answer. All right, thank you guys for playing. Come talk to me with questions. We'll talk to you soon.